Hi, I'm Dave Herman with TEC Tube. Today we're going to be going over some rooftop maintenance. We'll be going over the cleaning of the unit and getting some basic readings and numbers to make sure your unit's operating properly. Now we're going to go over checking some numbers on the unit while it's operating. We're going to be checking amp draws on a few items just to make sure the unit's running in the range that it should be. Things we're going to be looking at: compressor, condenser fan, and our blower. So on the side of the unit, there's going to be a tag that's going to list all the running load amps, total amps, all the information of the unit, operational information that we need to reference to know what we should be running at. So that way we could take a look, see what the actual amp draws are on, whether it be a motor, the compressor, the blower motor, and make sure that they're at least operating, within range of where they should be. And that'll let us know if there's maybe something else going on, if there is a problem with that amp draw. So first off, we're going to locate our wires for what we're talking about. Always when we're doing this, we have to be careful. The unit is powered, so when we're taking our amp draws, obviously it has to be operating. So whenever we're reaching in, we want to make sure we know where we're going with the wires and we're in an area where we're not going to be touching anything that could be a shock issue. So first off, we're going to get the wires right in front here. I've already kind of gone through this, and I know for sure that these are condenser fan wires. So I'm going to get my amp probe. I'm going to get that out. Most of them multimeters now. They're amp clamp, and they do, regular voltage and other readings. So I'm going to get this clamp meter, set it to amps, and I'm going to get it. I'm going to get on one of the wires from the motor to black, which is going to be one of our power leads. I'm going to get that reading, and right now we're reading at 1.14, 1.13, and it's going to be holding right in there. So that's pretty close to the range that we should be running. We never want to be over the range or drastically over, maybe slightly depending on load, depending on conditions, depending on heat. But ideally, we're at that range or maybe, slightly below. So we take a look at that. We make sure we're good. Right now, we're running one fine on this one. Our conditions right now, we're working inside a building, inside a lab. So we don't have duct work on this unit, which doesn't matter as much on our outdoor part. But this will all matter. When we have a heavier load outside, higher temperatures outside on our AC, our draws may be different just because of the unit operations. So we checked our condenser, fan motor. Now we're going to go with our compressor. Our wires are going right out in the same direction because those are located in the same section of the unit. So I'm going to come over to our compressor wires, and same thing. I'm going to get on one of those wires, just one. So I'm on the black wire. It chose the black again. And right now, we're showing about 8.5 amps, and that's as we're running. So this is below what we're rated at on this unit, which is not really an issue. We're not really under much of a load in here at all. And our last one we'll go to our indoor blower, which is going to be behind this section on, behind this door. We always want to keep that door on. That's going to give us the most accurate reading because of our static pressure, which is going to change if we take that door off. So we want to keep this door on, attached to our ductwork, everything sealed up, as close to normal operation as possible. Again, our wires are coming through. I've already isolated the wires for the motor. So I'm going to grab the black. I'm going to clamp onto that. Again, just the one single wire. And we are running about 3.2 amps on our blower motor for the unit. So this is going to give us an idea of what's going on. If amps, again, are running high, we know there's a problem with possibly the motor itself. Say on the indoor blower motor, if the amp draws real high, is it because our static pressure? Do we have restrictions somewhere? Are we not getting air to the unit? On the compressor, if we have high amp draw, is there a problem with the compressor? Is the refrigerant charge off? is there something else going on there? Amp draw is going to give us an indicator of what may be going on in the unit. So it's a good reference when you're just doing a check on a unit. As you're doing maintenance, get the amp draws, reference your information tag, and make sure those amp draws are approximately, at the label or ideally maybe just below. Okay, now we're going to go over temperature drops, possibly temperature rise, depending on what we're talking about. Referencing the temperature the unit's operating at, putting out, is going to tell us again how it's operating. It'll indicate if we have dirty coils, if we're having a problem somewhere with the unit. So quick, relatively simple to check. If we're out on the unit outside, on the roof side of the building, right here, this side of the unit's going to be our return. This is going to be our supply. So we could access directly from here. Now, if we were in a different situation, say in a building, in an office building, you'd be able to do this exact same thing right below the unit where you have your ductwork drop. So what we're going to do, this unit we already use as one of our demo units, so we have some pre-drilled holes here that are just plugged. Just going to pull the plugs. I'm already set. I have my meter on to degrees. I'm going to slide in, and I'm going to get in, and this is my return. This will be my return side. So if we were below doing this from the ductwork, it would be our return run right below the unit. This is direct. This is actually a lot more accurate what the unit's doing because we're doing it at the unit than if we were doing it just below the unit in the ductwork. It's kind of holding there. So now I'm going to go into the supply side, which also when we're doing this, if we're doing it in the heating, we'd have to be careful because our heat exchanger is in here. So we've got to make sure we don't touch the heat exchanger with our probe. So we're only showing a 51 degree supply air temperature. It's dropping to about 50, between 50 and 51. So right now we only have about 11 degree drop on our AC. Normally on AC, we're looking for somewhere 18 to 20 degrees, roughly. It could be, slightly less than that's okay. Ideally that temperature, 18, 19 degrees, that's kind of a good spot to be at. Now, if we were running in the heat mode, we'd do the exact same thing. Return temperature, supply temperature. Again, we could do it just below the unit in ductwork, if that's the case, or even a side discharge. If we had this ductwork attached to the side of the unit, we'd be able to access there also. But when we get in on the heat side, again, we get just inside. Be careful, make sure when you touch and put that in, make sure you're not hitting anything metal, because that would be the heat exchanger, and that temperature is going to be extremely hot on that heat exchanger. So you just want to be in the airflow. The heat rise is going to be different on units depending on the unit you're talking about. This unit and all units on the heat rise, it will be listed on the information tag where we find our amp draws and all the other information. This unit happens to be 55 to 85 degree temperature rise. So the normal range would be somewhere for your temperature rise, 55 degrees to 85 degrees between your return and your supply. Obviously, being at that maximum isn't ideal because then we're actually running kind of warm. It's always best to be down towards the lower end of that. Then you're usually in a safer range. Things are more comfort, a nice steady heating in the heating mode. Same thing with cooling. High temperature drop is going to drop that temperature too quick. So we're kind of looking for more reasonable temperatures for comfort, cooling, and heating. We're going to go over coil cleaning now. We're going to do it on the rooftop unit. We're going to start with the condenser coil first. So when cleaning the condenser coil, we don't want to clean from the outside in. We want to clean from the inside out. We don't want anything that's sitting on the outside of this coil getting, embedded inside that coil, getting stuck there to a point where at some point it may not want to come out at all, which will affect the operation of the unit, cause pressure issues down the road. So we want to get everything pushed out of the coil and get it as clean as possible. Some different ways to do that. You can use coil cleaner depending on how dirty the coil is. Different coil cleaners you could use. In a lot of cases, you're able to just use a hose, you know, plain water. You won't need any coil cleaner. Situations, restaurants, manufacturing, depending on where you're located, sometimes these units will get all kinds of debris, oils, stuff we're not even sure what it is sometimes. We got to get that stuff off. And in those cases, we definitely want to use some type of coil cleaner. There's a lot of different ones out there, environmentally friendly, some not so friendly, specifically for condenser coils, some for evaporator coils, some that'll do both coils. So basically just whatever type of cleaner you need, you want to check that cleaner, make sure you have the right mix, and then just go from there with it. So initially what we're going to do, we're going to see how bad the coil is, if we need a cleaner, if we don't. I do have a sprayer here with some cleaner. I have it mixed already. Always follow the instructions on your coil cleaner, whatever you have, and you don't want to mix it too strong. You don't want to damage the coil, and you don't want to damage anything that might be around it. You might be in an area where you have landscaping, something else. All situations are different. So you always want to follow the instructions on the coil cleaner for the mix. I'm just going to spray this down. Then we're going to open up the unit from the top because we are going to rinse it from the inside out. Depending on how dirty the coil is, if it's really dirty, you could get the cleaner on both sides. If you have foaming cleaner, your foaming cleaner will actually push stuff out of the coil. So you can do it from the inside, you can do it from the outside. It'll push stuff out of the inside of the coil also. So this is a non-foaming cleaner, just a pretty basic, simple cleaner. So I'll spray down the coil. It's a light mist, so it's not going to push anything into the coil itself. The inside of this coil and the inside of the unit isn't really dirty at all, so I'm not too concerned about that. So I'm not going to worry about spraying it from the inside, more just doing it on the outside for the demonstration purposes today. This coil actually comes around from the side too. On this side underneath where our control compartment is. So I'm going to get some cleaner on that also. All cleaners are different. Some have to sit on the coil longer than others. Again, follow the instructions on the coil cleaner, and that'll explain as far as time, how long it may need to sit, foam, whatever the case is, depending on the cleaner. So I'm going to let this sit on here a couple minutes, and then I'm going to open the unit up and start cleaning it off. Okay, the coil cleaner has been on there for about 5 minutes. We're back. We're going to open up the unit now. This unit sits up higher because of the curb it's on, so I'm up on the ladder. So I'm going to pop the top off quick. Normally with the units, there's plenty of wire that you could come out a little bit loose, get it back out of your way. So now I could sit down, look into the unit. Got my hose ready to go, and now I'm going to flush this out from the inside. I want to be careful, depending on the hose I'm using, that I don't have too much pressure. I don't damage the coil in any way, bend the fins over. Pressure washers, not usually a good idea. You usually end up damaging the coil. So it's always best to just try using standard hose with, you know, regular water pressure. Just going to get this hosed out from the inside. I'm going to rinse all that coil cleaner off. Be consistent, make sure I get everywhere. Depending on how dirty that coil is, you'll see a lot of the junk flushing out of it. You may have a lot of cottonwood on it, depending on where the unit's located. In our cases, there's a lot of cottonwood. We could also hit that from the outside. Again, we don't want to blow into the coil with the water. We want to go from the inside out, not outside in. So we're essentially going to do that, make sure we're thoroughly rinsed, make sure we got pretty much everything blown out. We could come back to the outside. If for some reason we still have, you know, cottonwood or debris on the outside of the unit, we could rinse it from the outside, but we want to do it on a downward angle. So we're not, I'm going with light pressure on the coil. We're just gonna rinse it down, downward angle, so we're not pushing anything into the coil. Just any surface debris that might be on there, we're gonna knock off. You can see we're still flushing some of the coil cleaner out of there. We just want to get everything off the coil and out of the inside of that coil, so our unit maintains good operating pressures when it is running. Maintenance is critical on units, and keeping the coils clean is the main part of that. So I'll go through this until I get this coil, fully clean, all sides of it. I'll hit this side, the other side. I may go back on the inside, flush it out again, depending on how dirty it is. I talked about grease problems, restaurant areas. I may get coil cleaner on there again, may clean it multiple times, just depends how dirty it is. Okay, we're back around the other side of the unit now, back near the evaporator coil section. The condenser coil is taken care of, it's clean. Now, the evaporator coil we got to treat a little bit differently. I've already pulled off the economizer section to this so we can get full access to the evaporator coil. So I'm going to pull the filters off, slide them out of here, and get them out of the way. Ideally, we never have to worry about cleaning the evaporator coil. If filters are changed regularly, the unit's maintained properly, hopefully the coil will stay clean. But at some point, if you get to that time when it needs to be cleaned, almost in similar, we could do it kind of the same way, minus the hose. Generally not a good idea to run a hose when we're blowing into a unit, which is right above the inside of the building. So we're gonna use coil cleaner if needed. In a lot of cases, there's different varieties. There's aerosol cans you could use that are rinse-free. There's actual mixes you could use that are rinse-free. So you have different options. Again, check your coil cleaner that you're using, what's best for your job. That's what you want to use. The coil cleaner that I used on our outdoor coil was able to be used on the indoor coil also, but it is one that needs to be rinsed. So in that case, I would take it same way. I'd soak down my coil. That would break down any grease, debris on there. And then I would just, in that same bottle, different bottle, whatever I want to use, and then I would just use water to rinse it down carefully, because I'd want that to drain off, go right into my drain pan off the coil and drain out of the unit. I don't want to be careful that I don't have any of this dripping down into the unit itself, which is then going to drip down into the building and cause a problem. If you get to a coil that's really dirty, really bad, you come up on a unit that hasn't had filters in a while, you also have options of brushing a coil off. Here's a simple furnace brush, any type of brush. You could actually take it carefully again, because we don't want to push stuff into the coil. We don't want to damage the coil. Just lightly take it and brush down and knock any of that debris off the coil. And then we could take a vacuum, clean that up, or as we get it down in the drain pan, we could just scoop it out and throw it out. But vacuum sometimes will suck some of that debris off. It just kind of depends whether that's wet or not at the time you're dealing with it or not. Furnace brushes are kind of nice for that because they're very soft. So usually you don't have to worry about damaging a coil at all with the furnace brush if you use it, but in some cases they're not strong enough to get the debris on there. It's been on there a while, or kind of gets cemented on there over time because it gets wet from condensation, dries, hardens over time. So that's the main thing. Depending on how bad the coil is, what type of cleaner you're going to use, how you're going to go about cleaning it, is it going to need to be rinsed or not? And then again, we could go to the other side of that coil depending on how dirty it is also, and clean that side also, clean from the other side, possibly use a foaming cleaner if it's really bad and you got to use it. The thing you got to worry about with certain cleaners though are the odors it might give off and fumes. It might be a problem if there's people in the building, and there may be issues there. So always be aware of the type of cleaner you're using when you are cleaning coils. Okay, when doing the maintenance, along with the coils and cleaning, we also want to make sure our condensate trap gets cleaned. This condensate trap is going to run the condensation from our evaporator coil on our AC from the unit onto the roof, onto the ground, wherever it's draining to. We want to make sure this is clear, because if this gets backed up, we could have backup into the pan at the evaporator coil, which will then back up into the building that we're sitting on. So to clean that out, generally all we're gonna do is twist this off. It's just screwed in. A lot of cases it's gonna be 3/4 PVC fittings. It may be metal pipe, just depending on how it was installed. Traps could be different sizes and configurations. We're just gonna take that off. We can make sure our immediate fitting on the unit doesn't have any debris in there. We could clean that out, and then we could dump this out. We could also flush it out with a hose. If it's tighter, we could grab our channel locks, get it off with a pair of channel locks, and then after it's all cleared out, flushed out with the hose, whatever we have to do, we could just get that screwed back in, put right back into place. It doesn't have to be super tight, but we do want it snug. And then just get it back into place. This way we know the water is going to flow out of the coil pan as it needs to, and we won't have any water problems on the inside.